Namaskaram everyone. Welcome to Mathematics webinar series. As a part of Mathematics 1A chapter, we have started with matrices. We shall continue that after a while. Now we will start a new topic which you already got introduced in your earlier classes. That is trigonometry. Students, even when you were learning functions or when you started matrices, you have seen trigonometric functions there. While finding the trace of a matrix also, sine square x plus cos square x, how much it was, identities of trigonometry were used. Even in trigonometric functions, during functions chapter also, you have come across trigonometric functions. So we thought trigonometry, when it has applications in even other topics of mathematics, we shall continue with trigonometry first, and then we can go back and view the previous lessons as well, where trigonometric functions were involved. The presenter for today is well known to you, Madam V.USHASREE, PGT Mathematics from TSMS Velimala, has taken your first year chapter 1 from Mathematics 1A functions, and now she's ready to teach you trigonometry. And to begin with, Madam has actually gone back to the introduction of the various systems of measurement of an angle. From there, Madam is going to start. So students, please make optimal use of this and revise what all you have learned in your earlier classes. You must have conveniently forgotten also. But now, Madam is going to take you trigonometry chapter with the introduction to trigonometry, starting from measurement of angles and various systems. Then from there, trigonometric ratios, identities, and few problems based on that. I take this opportunity to welcome V.USHASREE Madam. I'm so happy and delighted to introduce you, Madam, time and again.
Thank you.
Even during second year sessions and again for first years. Over to you, Usha Madam. Welcome.
Thank you, Madam. And I am also privileged to present the topics to the model school students under your guidance, Madam. Thank you. Good afternoon, everyone, children. Hope that you have worked out the problems what we have discussed and the concepts what we have discussed in functions. Now today I'm here with a new topic, trigonometry. This topic actually it is heart of, I should say, the first year 1A. Almost 50% of the syllabus in paper 1A is totally on trigonometry. And not only that, trigonometry peeps into all the topics throughout in the intermediate concepts. Okay, so let us try to learn what actually is trigonometry. Of course, you had introduction of this topic in your class 10, but still what you have learned there is very, very, very basic concepts. Okay, we will get into the depth of the topics as we move further into different concepts of trigonometry. Now, children, trigonometry, it says tri stands for 3, isn't it? Gono, they are angles. Metry, some measurement. We are trying to take the measurement of 3 angles which we find in a triangle. So this is simply, we can say it is the measurement of angles and how they behave in different quadrants. We will try to discuss in this session. Now today we are going to see the systems of measurement of angles and the relation between them. Then we will see trigonometric ratios and the variations and the variations, how they vary in different quadrants. Then we'll see signs of trigonometric ratios in the 4 quadrants, how the sign is changing. Then the values of the trigonometric ratios with standard angles, what you have learned in your class 10, and also little extension of that. Then we'll see the identities, trigonometric identities. Then we will also discuss some problems based on the concepts what we are going to look into today. Right, children? Now, getting into the topic, as I told you, trigonometry is totally a discussion of angles in a triangle, isn't it? Now, measuring an angle will should have some system, okay? Some system of measurement. Now, for measuring the angles, we have totally 3 systems, children. One is the sexagesimal system, then centesimal system, and circular measurement. Regarding this, we didn't have any introduction in class 10, right? So now, as I was mentioning again and again, angle, right? Now, if you take a point on a plane, every one of you know that around a point on a plane, the angle will be 360 degrees, isn't it? Now that 360 degrees, how it is taken in different quadrants, we will try to look into. Now in sexagesimal system, one right angle is divided into 90 equal parts. Now what does this mean? Now when I said around a point it is 360 degrees angle, it will be divided into 4 equal parts, children. Each part will be taken as a right angle, or in fact we are learning it as 90 degrees, right? So here that right angle what we are getting is divided into 90 equal parts, and each part we are calling it as 1 degree, right? So one right angle is equal to 90 degrees. This is what is taken in this system, right? Now at the same time, 1 degree is again divided into 60 equal parts, and each part we are calling it as a minute. So 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. Now from this we can also say one right angle is 90 degrees. It means 1 degree is nothing but 1 by 90. So if I say D is the degree, then degree can be calculated the theta can be calculated as theta, which represents the angle. Okay, it can be taken as D by 90 right angles. That we will see in the next coming slide. Right, the next system is centesimal system. Cent stands for 100, isn't it? So here, one right angle is divided into 100 equal parts. Now each part will be considered as 1 grade. Each part will be considered as 1 grade. So we can say one right angle is equal to 100 grades, and 1 grade is equal to 100 minutes. Right, children? So 1 minute is equal to 100 seconds. Now just please check this one. It is 1 minute is equal to 100 seconds, children. Then before I go to the circular measurement, I would like to say 1 grade is equal to 1 by 100 right angles. Or if I have to write the angle theta, then I can also take it as G by 100 right angles. Okay. Now the next one, circular measurement. Now in circular measurement, the unit of measurement will be taken as a radian. Okay, we call it as radian. Then what is this radian? 1 radian is the measure of an angle subtended at the center of a circle by an arc of length equal to the radius of the circle. Now what it is, we will try to understand with the help of a diagram. Now, angles at the center of the circle are proportional. Angles at the center of the circle are proportional, right? So we will just take a circle with center O, and I am taking the diameter. AB is the diameter. Now, what is diameter, children? Diameter is nothing but double the radius, isn't it? Diameter is double the radius. Now, at center O, if you take center will be the midpoint. Now, what is that we are taking when we talk about a radian? Radian is the measure of the angle subtended at the center of the circle, right, by an arc of length equal to the radius. Now, we'll try to understand what it is. Now, I am taking another radius so that it forms an angle at the center. It forms an angle at the center. Please observe this. Okay, so when this angle is formed, what is that angle I'm taking? AOP. AOP is the angle. Now, what is so special about AOP? The length of the arc from A to P is equal to the radius OA or OP, isn't it? These two are radii, right? So AP is equal to AP, the length of the arc is equal to the radius. Then in this case, the angle subtended at the center is nothing but 1 radian. Now, how to take this? Now, as we have seen, angles at the center of a circle are proportional to the arc subtended by them. How do you take the proportionality? Now, about this proportionality, little of the things you have studied in your similar triangles concept of your 10th class and also in your 9th class when we were discussing circles topic, right? So, angle AOP, that is this 1 radian what we have, by angle AOB. What is this AOB from here till here, right? What is this angle? This is angle at a point on the straight line, which will be equal to 180 degrees, isn't it? They form a linear pair over here, right? So angle AOP by angle AOB is equal to length of the arc AP by arc APB, this whole part, that top half of the circle, right? So we can always replace angle AOB is equal to 180 degrees as we have seen just now. Arc AP, this AP arc is equal to the radius what we have taken just now, isn't it? We were discussing regarding that. So we will replace arc AP with R. R stands for the radius, and divided by arc APB. What is this APB? Half the circumference. Half the circumference of the circle. Circumference of the circle is 2 pi r. Half of it will be pi r. Now here if you cancel r and r, you will be left with 1 by pi, right? So we can take it as angle AOP is equal to 1 radian. This is equal to 1 radian, which is equal to 180 degrees by pi. Now children, having learned these three systems of measurement of angle, regularly in the concept what we are dealing in intermediate, we will be using radian measure and also sexagesimal measure, right? Centesimal system generally we will not use unless a problem like conversion type of things from grades to degrees or to radians, if it is given, then we will use that type of measurement. I mean, that is centesimal system. Now we'll try to draw some relation between the three systems of measurement of angles. Now, as we were mentioning, sexagesimal system, it deals with degrees. Then we will see radian measure in circular system. And then in centesimal system, we will see grades, isn't it? So just for our convenience, we will say let D be the number of degrees what you're taking, right? And R be the number of radians and G be the number of grades. Then, as we were discussing, one right angle is equal to 90 degrees. It is also equal to 100 grades, and it is equal to pi by 2 radians. One right angle is equal to pi by 2 radians. So as I was talking, like theta can be taken as a d by 90 right angles, or it can be taken as a g by 100 right angles in Sentecimal System, or you can also say 2r by pi, 2r by pi in radian measure. So when you represent theta, theta is nothing but d by 90. It is also equal to g by 100, and it is equal to 2r by pi. Now, what is the use of this formula? Now, if you're given some measurement of angle in degrees, then you can always convert it to circular measure or to the grades, right? If grades are given, you can go with radians and also degrees, right, children? So this is one of the formula which can be used to convert from radians, conversion of the given angle in three different systems. Now, in general, the most useful part will be d by 90 equal to 2r by pi. All right, but you need to know the other one also. It is equally important, right? Now, quickly we will move into trigonometric ratios. Now, trigonometric ratios already you have studied in your class 10, isn't it? What are the different trigonometric ratios? We have 6 trigonometric ratios, children. The 6 trigonometric ratios what you have are sine, cosine, tangent, cotangent, secant, and cosecant. Now, in short, we will be taking sine, cos, tan, cot, isn't it? But you need to know the full name of the trigonometric ratios also, right? Now, here in this chapter, we will try to confine with the trigonometric ratios with a right-angled triangle only. But it doesn't mean that we can apply trigonometric ratios only to a right angle triangle. In class 10th, you have studied only with right angle triangle, and in this chapter here also, we are dealing only with a right angle triangle. But as I was mentioning right in the beginning of the class, I said trigonometry is a measurement of three angles, or it is a study of three angles of a triangle. Now, when we say three angles of a triangle, it doesn't mean that it should be a right angle always. Okay, it can be any type of triangle what we are taking, right? So right now we will talk only of right angle triangle, and in further when we proceed with the topic, we will also go with other type of triangles also. Now, let OP represents a ray making an angle theta with a positive direction of x-axis. Then, observe this. You have the coordinate axis. You're taking a point P with coordinates x and y. Okay. Now, the ray OP is making some angle with x-axis. Now, what x-axis you are taking? It is mentioned as positive direction of x-axis. Then what is this positive direction of x-axis? If you take the angle in the anti-clockwise direction, what do you mean by anti-clockwise direction? I don't think I have to tell you. Clock will move in this direction, isn't it? But it is moving in the opposite direction. So it is anti-clockwise direction. Now, if you're taking the angle in the anti-clockwise direction, you say the angle made with the x-axis is in the positive direction. Now, here when we take in the anti-clockwise direction, we call it as positive angle also. Now here, as the point says, the coordinates of the points are x and y. So you are taking x distance on the x-axis and y on the y-axis, isn't it? So here it is forming a right-angled triangle. Now in this right-angled triangle, the side opposite to the angle theta, always it will be taken as opposite side as you have studied in your previous classes. And this side with the length x, it is just beside the angle. Therefore, we call it as the adjacent side. Now, this OP, length of OP is taken as R. I can also say it is the hypotenuse because the angle opposite to 90 degrees, the side opposite to the angle 90 degrees is nothing but hypotenuse. And the very important point to note is hypotenuse will be the longest side in a right angle triangle. Okay, children, having discussed this, we will try to take what is sine theta. As you know, sine theta is opposite by hypotenuse. Here the opposite side is y, and the hypotenuse is r. So sine theta is y by r. And likewise, cos theta is adjacent by hypotenuse, that is nothing but x by r. Then tan theta. Tan theta is nothing but sine theta by cos theta. So we can also take it as opposite by adjacent, isn't it? Opposite by adjacent, so we are getting it as y by x. Then cot theta. Cot theta is nothing but cos theta by sine theta, or you can mention it as 1 by tan theta, or you can also take it as adjacent by opposite. So cot theta is equal to x by y. Now secant theta. Secant theta is nothing but 1 by cos theta. 1 by cos theta, reciprocal of cos. So it is hypotenuse by adjacent. So hypotenuse r by x. Now cosecant theta. Cosecant theta is nothing but the reciprocal of sine theta. So reciprocal of sine theta is nothing but hypotenuse by opposite. So it is nothing but r by y. Right, children? So these formulas already you have seen in your previous classes. You can say it is a recall of all your previous formulae. Right. Now we'll try to discuss signs of trigonometric ratios in the 4 quadrants. Now, when I say 4 quadrants, we will start with 0 degrees at this point as the initial measurement of the angle, right? Then when we move on to this point, it will be 90 degrees because the angle here is 90, right? And still further, if we reach here, the angle made will be 180 degrees. Still further, if you move here another 90 degrees, so it becomes 270 degrees. From 270, again, if you move another 90 degrees, it will be 360 degrees. That means after completing one rotation, if you are reaching to the initial point, then the angle made will be 360 degrees. Now, still further, if you are moving, again, it will be 360 plus 90, and further moving, another 90 will be added, and so on. Right? Now, here, in the first quadrant, when we talk of how will be the angle? The angle what you're taking in the first quadrant will be more than 0 degrees, but less than 90. So we will take it as 90 minus theta. Okay. Now, if we go to the second quadrant, it will be more than 90, right? So we will take it as 90 plus theta in this quadrant. At the same time, the angle will be less than 180. So we will represent it as 180 minus theta. All right, children. Now, quickly, we will see the third quadrant. In third quadrant, the angle taken will be more than 180. So it will be 180 plus theta, and less than 270. So it should be 270 minus theta. Now, still further, if you move to the fourth quadrant, it will be more than 270 and less than 360 degrees. Now, after 360, after completing one rotation, still if you are moving an angle less than 90 degrees, then it will fall in the first quadrant, that is 360 plus theta. Hope that you have followed what is this 90 minus theta, 90 plus theta, and so on. Now, based on these angles and the quadrants, we have a small acronym which you need to remember throughout till you keep doing mathematics, because trigonometry is not going to leave you so easily, right? So in the first quadrant, we take A, second will be S, third one T, and in the fourth quadrant, you will take it as C. This is Astc property. Now, in general, we remember this acronym with all silver teacups. All silver teacups. Okay, A stands for all. A stands for all. All means what? The 6 trigonometric ratios what we are taking, that is sine, cosine, tangent, cotangent, secant and cosecant. Not only the short names, children, you need to remember the full name of the trigonometric ratios also. And S stands for sine and its reciprocal. Sine and its reciprocal is cosecant, right? And T stands for tan and its reciprocal, that is tangent and cotangent. Then C stands for cosine and its reciprocal, that is secant. Now, what is that? What is that we are gaining from this table or Astc property? Now, this Astc property says all the trigonometric ratios, whatever you are mentioning here, they will be positive in the first quadrant. In the second quadrant, S, that is sine and cosecant, will be positive. Then what happens to the remaining? The remaining 4 other than this will be negative in the second quadrant, right? Then in the third quadrant, tangent and cotangent will be positive and the remaining trigonometric ratios will be negative. So in the fourth quadrant, we can say cosine and secant will be positive and the remaining will be negative, right? Negative part we are not remembering, because when we take the positive cases, all the remaining will be negative, right, children? So from this Astc property, you can give the sign of the trigonometric ratios in the 4 different quadrants. Now, why the sign is positive in the first, second, third, and fourth for few trigonometric ratios? Why not others? That we will see in the next slide. Now, children, look at this table. Look at this diagram. Now, in this diagram, when you look at the angle taken is in the anti-clockwise direction, and the point which you are picking here is in the first quadrant. When a point is taken in the first quadrant, what does it mean? The x and y values what you are taking are greater than 0. Greater than 0, it means both the values are positive. And not only x and y, r is also positive. Now, 3 values are positive. See, for all the trigonometric ratios, what are the different terms you are using to write the formula? Opposite, adjacent, and hypotenuse. Now, here in this diagram, if you observe, opposite, adjacent, and hypotenuse all are positive. So, in the first quadrant, all the trigonometric ratios, whatever you are taking, are positive. That's what A stands for. All are positive, right? Then see the second diagram. You are taking the angle in the second quadrant, right? And of course, the angle is taken in the anti-clockwise direction. Now here in the second quadrant, if you pick up a point, right, then x will be negative and y will be positive. What is this x? X is nothing but the adjacent side, right? And y is nothing but the opposite side, right? So now what is negative here? Adjacent is negative. Remember this, adjacent is negative. So for sine, what is that you will be using? Sine will be taken with opposite by hypotenuse. Opposite is positive, so opposite by hypotenuse, that gives a positive value. At the same time, cosecant. Cosecant is nothing but hypotenuse by opposite. So hypotenuse and opposite both are positive. Now look at the other formulae for tan, cot, secant and cosecant. Tan will involve adjacent. Wherever you have adjacent, all those trigonometric ratios will be negative. So you will not find adjacent in the formula for sine and cosecant. Therefore, sine and cosecant will be positive in the second quadrant. That is what S stands for. S stands for sine and cosecant. They will be positive in the second quadrant, right? So here x is less than 0 and y is greater than 0. That you need to note, right? And the next one, we are taking a point in the third quadrant. Excuse me. Right. So in the third quadrant, both x and y, both are negative. Both are negative. Right, children? So that means what? Adjacent is negative. Opposite is also negative. Okay. Now, what about the hypotenuse? Hypotenuse, opposite square plus adjacent square under root. When you take that, r will automatically become a positive value, right? So now, if you take sine and cos, both will involve one negative and one positive value. That is, sine is opposite by hypotenuse. So negative by positive, right? Cos is nothing but adjacent by hypotenuse. So negative by positive. Both of them will be negative only. But if you take tan and cot are opposite by adjacent and adjacent by opposite. Both are negative in the numerator and denominator. So negative values get cancelled and both of them become positive. And likewise, secant and cosecant, when we discuss, they involve only one negative value in the formula. Therefore, they are negative. So we are left with only two positive values, that is tangent and cotangent. That's what T stands for, right? So next, the last one in this, you're taking a point in the fourth quadrant. In fourth quadrant, what is negative? The y value is negative. That is your opposite side, right? Adjacent is positive here. So in this case, where is that? You will be taking positive value. Adjacent. Adjacent will be taken for cos and secant, isn't it? Cos theta is adjacent by hypotenuse and secant theta is hypotenuse by adjacent. Both of them will be positive over here. So in the fourth quadrant, you have x value greater than 0, that is a positive value, and y value less than 0. So from this, we can confirm that Astc property, that in the first quadrant, A stands for all the trigonometric ratios to be positive. In the second quadrant, only the sine and cosecant will be positive. In the third quadrant, tangent and cotangent will be positive. And in the fourth quadrant, cosine and secant will be positive. And the remaining will be negative. Right, children? Now, all this time, we were talking of the angle taken in anti-clockwise direction. What if we take the angle in the clockwise direction? If we take the angle in the clockwise direction, we are moving in the negative direction, right? So we call it as the negative angle and we represent it with minus theta. Now, how it looks like, we will see. Now, these are the coordinate axes, what we are taking, and you're taking a ray which is of length r. Okay. Now, you're also taking an angle with measurement theta, right? With equal measurement, you are taking the angle, right, in the anti-clockwise, in the clockwise direction, in the opposite direction of this. This is anti-clockwise direction, this is clockwise direction, right? So magnitude of the angle will be same, but opposition in direction. Therefore, we represent it with minus theta. This minus theta is also equal to 2 pi minus theta. How? We will look into this. See, here is a point. At a point, totally the angle taken will be 360 degrees. Pi stands for 180, children, as we have seen in the radian measure, right? That is 2 pi will be 360 degrees. So this 360 totally minus this theta. Observe this. From this, you are removing this theta. So 2 pi minus theta is also equal to minus theta, isn't it? So taking that, sine of minus theta will be taken as minus sine theta. How? Look at this. Sine of 2 pi minus theta is nothing but minus sine theta, because 2 pi minus theta is in the third quadrant. 2 pi minus theta, 2 pi is 360 minus theta, that is fourth quadrant. Okay, so in fourth quadrant, sine is negative. And this minus theta is also falling in the fourth quadrant only. So that is the reason why you are getting it as a negative value for sine of minus theta. But if you talk of cos of minus theta, cos is positive in this fourth quadrant, so you are getting it as a positive value, right? So sine of minus theta is equal to minus sine theta, and cos of minus theta is equal to cos theta. Now remember this, children. If you can recollect your functions topic, when I was talking of functions, we have seen even and odd functions also, right? If f of x is a function, then f of minus x, if it is equal to minus f of x, then the function is odd. At the same time, f of minus x is equal to f of x, then in that case, we call it as an even function. Now you can relate this to even and odd functions. Sine is an even function, but sine is an odd function, but cos is an even function. Now, sine of minus theta is minus sine theta, cos of minus theta is cos theta. So from this, you can calculate tan of minus theta. Tan of minus theta is what? Sine of minus theta by cos of minus theta, which is nothing but minus tan theta. Then what is cot of minus theta? 1 by tan of minus theta, which is nothing but minus cot theta. Right? Now, secant of minus theta. Secant of minus theta is what? 1 by cos of minus theta. So, which is nothing but secant theta itself. Now, cosecant of minus theta is nothing but 1 by sine of minus theta, which is nothing but minus cosecant theta. Now here you need to remember, if you can remember sine and cos, you can always write the remaining trigonometric ratios with a negative angle. I'm sure that you have followed the concepts till here. Now we will look into the standard values for the trigonometric ratios, what you have seen in your class 10. With standard angles. What is that standard angles you have seen? 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. But here in this class, you are going to see 180, 270, 360 degrees, 15 degrees, 75 degrees, and so on. Okay, I'm not going to scare you by telling all this, but for everything, there is a logic, children. With that logic, if you can proceed, it's very easy to calculate, right? Okay, quickly we will look into the table. We'll see the trigonometric ratio and the angle. We will first see 0 degrees, right? Pi by 6. What is this pi? Pi stands for 180. That is a radian measure. 180 by 6, that is 30 degrees. Okay, 180 by 4, which is 45 degrees. 180 by 3, that is nothing but 60 degrees. 180 by 2, 90 degrees. So you need to get acquainted with this type of representation also. Okay, 0, 30, 45, 60, and 90. Right? Now we will try to take the 6 trigonometric ratios what we have. First, we will look into sine theta. Now, to get the value of sine theta, I think this technique of remembering, maybe your teachers in the previous classes have told you, but we will try to recall, right? Now, we will just take 0, 1, 2, 3, and 4 just below these values with the standard angles, divide them with 4 and take the square root. Then we are going to get the sine theta values of this particular angles, what we have mentioned over here. Okay, so when we calculate in that way, we will get sine theta is equal to sine 0 degrees is 0, sine 30 will be 1 by 2, that is 1 by 4 under root will be 1 by 2, and sine 45 degrees, it will be 2 by 4 under root, that will be 1 by root 2, and sine 60 degrees, it is 3 by 4 under root, which will be root 3 by 2. Okay, and sine 90 degrees, 4 by 4 under root, which gives you 1. All right. Now, once you know sine value, it is very easy to remember cos values, cos theta. Cos 0 will be exactly the reverse way of this, right? Whatever you have for sine 90, you will have for cos 0. How and why, we will try to get the logic. Okay, we will try to get the logic in the coming slides. So cos of 0 degrees, cos 0 will be 1. We will come exactly in the reverse way, children. Cos 30 will be equal to sine 60, which is nothing but root 3 by 2. Sine 45 and cos 45 will be same, that is 1 by root 2. And cos 60 degrees, it will be equal to 1 by 2. And cos 90 degrees will be equal to 0. Now, once you know sine and cos values, you can always go for calculation of tan theta. Tan theta is nothing but sine theta by cos theta. So it is 0 by 1, which is 0. 1 by 2 by root 3 by 2, which is nothing but 1 by root 3. That is sine 30 is 1 by root 3. Now sine 45 will be 1 by root 2 by 1 by root 2, which is equal to 1. Okay, tan 60 root 3 by 2 by 1 by 2, which is nothing but root 3, and tan 90 degrees 1 by 0. Any number by 0 will be an undefined value. Okay, in a few books it will be taken as infinite value also, because infinity is also not defined. Now, once you know tan theta, you can also calculate cot theta. It is simply the reciprocal of tan theta. All right. So cot 0 will be an undefined value, because 1 by 0, isn't it? 1 by tan, that is 1 by 0 will be an undefined value. 1 by root 3, which is nothing but root 3. 1 by 1 is 1. Okay. Then 1 by root 3 will be 1 by root 3. 1 by undefined value, that is 1 by 0 gives you 0. Okay, that means exactly in the reverse way we are proceeding to get the value. Now, till here when we see, observe these two values, children. Sine 45 and cos 45 will be same. Tan 45 and cot 45 will be the same values. Okay. Next, secant theta. Secant theta is what? 1 by cos theta, right? 1 by 1 is nothing but 1. So secant 0 degrees is 1. Secant 30 will be 2 by root 3. And secant 45 will be root 2. Secant 60 is 2. And secant 90 will be an undefined value, because 1 by 0 will be an undefined value. Then cosecant theta. It is nothing but 1 by sine. 1 by 0 is an undefined value. And you can also take exactly the reverse way of secant. Then you will get cosecant, right? So 1 by 2, it will be 2. 1 by root 2 is root 2. Then 1 by root 3 by 2 is 2 by root 3. 1 by 1 is nothing but 1. Okay, children, till here you have already seen in your class 10, but still we try to recall all this. Now, the next angles what we are taking is pi. Pi stands for 180, what I was talking of, and 3 pi by 2. Pi by 2 is 90. 90 into 3 gives you 270 degrees. 2 pi, 2 into 180, which is nothing but 360 degrees. Okay, so sine 180 degrees. Sine 180 is exactly the angle what you have for 0 degrees, right? So sine 180 is also 0. Then sine 270 will have the same value as 90, but with opposition in sign, that is -1. And sine 360 degrees is 0 again, because at 360 and 0 will be at the same position. All right. Then cos, when you talk of cos 180 degrees is -1. That means it is equal to 0 degrees value in magnitude, but opposition in direction. So you're getting it as minus value over there. Regarding this, we will try to discuss in the next coming classes. Right? Cos 270 will be 0 and cos 360 is 1. Now, once you know sine and cos, the same technique what we have taken, sine by cos will be taken for tan. 0 by -1 will be 0, and -1 by 0 is an undefined value. 0 by 1 is 0 again. So tan 180 is 0, tan 270 is undefined, tan 360 is 0. Similarly, if you go for cot, cot 180 is an undefined value, cot 270 is 0, and cot 360 will be undefined. So likewise, secant pi is -1, secant 3 pi by 2 is an undefined value, and secant 360 degrees, that is 1. Okay, cosecant, when we talk of cosecant, is 1 by sine, 1 by 0, which is an undefined value. 1 by -1 is -1, and 1 by 0 is again an undefined value. So this is how you need to go by logic. Okay, once you are good at this, you need not mug up all these things, children. With a simple logic, you can remember the values of the standard trigonometric ratios with standard angles. Okay, now we'll try to look into some problems. Find the values of the following. Find the values of the following, right? Now, this one, sine 210 degrees. Did you see 210 degrees in the table? I don't think, isn't it? But still, we can calculate 210 degrees. Even if it is 2100 also, we can calculate. Right? Then you should get it out. Madam, we have discussed up to 360 degrees only. But how is that? You are talking of 2100 degrees. Since all the trigonometric ratios, what you have are periodic. They are periodic. So when they are periodic, they keep on rotating. After every rotation, it covers 360 degrees angle, isn't it? So regarding this, in the periodic, periodicity of the trigonometric ratios, we will try to discuss. Okay, so sine 210 degrees. Now sine 210 directly you cannot tell, and you cannot remember so many values, isn't it? So for that, we are devising some formulae for this. Sine of 180 plus 30 is also equal to 210 degrees, right? Sine of 180 plus theta. Sine of 180 plus theta. Where is this 180 plus theta? 180 plus theta is in the third quadrant. In the third quadrant, how is sine? Sine is negative. Okay, 180 plus theta. So 180, it is 2 into 90, or 180 plus theta, you will have the same function as your answer. Okay, so it is minus sine 30 degrees. Minus sine 30 degrees is not, sine 30 is nothing but half. Sine 30 is nothing but half. So this sine 30 value we will just substitute, and we will try to write the answer as -1/2. Okay, then quickly we will move to the next bit. Tan 480 degrees. Tan 480 degrees is nothing but tan of 5 into 90 plus 30 degrees. 5 into 90 plus 30. Okay, now 5 is 5 is an odd number, isn't it? Odd multiple of 90. 480 is nothing but 5 into 90, which is 450 plus 30. Now, in which quadrant it falls? This is important. 90 into 4 is 360. So, 90 into 4, when you take till here, you are reaching. You are completing one rotation and you are reaching this point. Then another 90 you have, so it should be in the first quadrant till here, plus 30. So it will come in the second quadrant. So 90 plus 30, 5 into 90 plus 30 is in the second quadrant. So you are getting a minus sign. Okay, regarding this cot 30 and all, we will try to see in the coming slide. As of now, we'll take it for granted that it is cot 30 degrees. Again, we'll come back to this slide. Okay, cot 30 is √3. So we will just substitute and we will take it as -√3. All right, children. Then secant of 2100 degrees. Secant of 2100 degrees, we can always write it as 360 into 6 minus 60 degrees. Now, what it is, we will try to understand first. 360 degrees means we are starting here, right? We are completing one complete rotation, and then we are reaching here. Then it becomes 360. Like this, how many rotations you are making? 6 complete rotations you are making. Okay, right. Now, after 6 complete rotations, you are here. But you're not completing the 6th rotation. You're just short of 60 degrees here. That means that should be in the 4th quadrant. In 4th quadrant, secant is positive. So you will get a positive value, and we will be taking it as secant 60 degrees. Why secant 60? We will discuss, right? Secant 60 is equal to 2. Okay. Now, cot of -315 degrees. Now, my cot of minus some theta. Cot of minus theta is minus cot theta. So I can write it as minus cot 315 degrees. But cot 315 degrees, you can write it as 270 degrees plus 45. 270 is here. Plus 45 will be in the 4th quadrant. In 4th quadrant, how is cot? It is negative. So minus of minus tan 45, which is nothing but which is equal to 1. Okay. Now this one also we will try to come back and we will look into this, children. Now quickly we will move to the trigonometric identities. How you are getting sine 30, cot 30, secant 60 and all we will discuss. I just wanted to show how the trigonometric ratios they are behaving, or I wanted to show the sign variation in different quadrants from these problems. Okay. Now, trigonometric identities. You are familiar with the trigonometric identities, what you have. So, what are the trigonometric identities? Sine square theta plus cos square theta is equal to 1. Okay. This is the first identity what you have learned. Then, secant square theta minus tan square theta is equal to 1. Now, for this is looking like a square minus b square form. So you can always write it as a plus b into a minus b, isn't it? So secant theta plus tan theta into secant theta minus tan theta is equal to 1. That means this is the other form of the same formula, right? Now the next identity is cosecant square theta minus cot square theta is equal to 1. In the similar way how we have taken this, we can also write this as cosecant theta plus cot theta into cosecant theta minus cot theta is equal to 1. Okay. Now, if one value, that is secant theta plus tan theta is given to you, then you can always go for calculation of secant theta minus tan theta by just sending this value to the other side. Right. Now, sine theta into cosecant theta is equal to 1. How? Cosecant theta is nothing but 1 by sine theta. So, sine theta and sine theta gets cancelled. So, you'll be left with the value as 1. Then, cos theta into secant theta is also equal to 1 because secant theta is 1 by cos theta. Then, tan theta into cot theta is equal to 1 because cot theta is nothing but 1 by tan theta, right? You need to remember these values, children. Now, right. Now we will try to make use of Astc property, sine and also angle, right? I was talking of the full names of the trigonometric ratios. Here I will come out with a very simple logic to remember all these formulas. Okay. Now, first we will look into sine of 90 minus theta is equal to cos theta. Now, how to remember this set of formulas? 90 minus theta is in the first quadrant. Whatever may be the trigonometric ratio, 90 minus theta, it gives a positive value in your answer, isn't it? So 90 minus theta is positive. That's why you're getting a positive value over here. 90 can be taken as 1 into 90. 1 is an odd number. Whenever you have an odd multiple of 90, then the function what you are taking in the answer, co will be added. Co-function of the function what you are taking. That means this is sine, right? So cosine will be in your answer. All right. Now let us see one more. Cos of 90 minus theta, as I was mentioning, 90 minus theta is in the first quadrant, so a positive value. Here you have cosine. When you have co, you are removing that co and you are writing, that is sine. Right? Here again, why you are doing it? Because you have an odd multiple of 90. Now, the same logic we will quickly apply to the next trigonometric ratios also, children. Tan of 90 minus theta. This is in the first quadrant, so positive sign. 90 minus theta, remember, this is telling you the sign, right? The sign variations we are seeing by Astc property. Then tan with 1 into 90, 1 is an odd number, so you should take co-function of this, that is cot. Now, if you're taking for cot, you remove that co and you write, you remove that co-function, that gives you a tangent, right? So likewise, secant of 90 minus theta is cosecant theta, co-function of this. Are you understanding? Then cosecant theta, cosecant of 90 minus theta, since it is in the first quadrant, in the answer you're getting a positive value, right? And you are getting a 1 into 90, 1 is an odd number, therefore you are taking off this co from the function and you're simply writing it as secant theta. Got it? This is the reason why I wanted you to remember the total name of the function, right? Okay. Now quickly we will look into sine of 90 plus theta. 90 plus theta is cos theta. Okay. Where is 90 plus theta? In the second quadrant. In second quadrant, what are positive? Sine is positive and cosecant is positive. All the remaining are negative, children. So you have sine here, so you are getting a positive value. Got it? Now this is 1 into 90, so you are taking co-function of this, that is cos theta. Now if you take cos of 90 plus theta, 90 plus theta, second quadrant, cos is negative, so 1 minus sine. Got it? And then 1 into 90, that is 1 is odd, therefore you are getting it as sine theta, that is you are removing the co-function. Likewise, tan of 90 plus theta, tan is also negative in the second quadrant, cot is also negative in the second quadrant, therefore you're getting a negative value. And of course, this is an odd multiple of 90, so when you don't have a co-function, you are adding co-function, and if you have that, you're removing and you're writing. I hope this will help you in remembering these formulae. 90 minus theta and 90 plus theta will tell you the sign and the odd and even function, odd and even multiples of 90 will be dealing with co-function and without co-function. All right. Now, secant of 90 plus theta is equal to minus cosecant theta, and cosecant of 90 plus theta is equal to secant theta. Now, in all this, if you can observe, in the second quadrant, sine and cosecant are positive. Look at this. All the remaining are negative. Right? I'm sure you're able to follow this. And quickly, we will try to reascertain the things with the next coming formulae. That is sine of 180 minus theta. Where is 180 minus theta? In the second quadrant again. Now, in second quadrant, what are the positive values, positive ratios? That is sine and cosecant only. But 180 is 2 into 90. So it is an even multiple of 90. When you have even multiple of 90, you will get the same function as your answer. If it is an odd multiple of 90, you will get a co-function, or if you have a co-function, you will remove that co-function and write. So this is a simple logic, right? So if it is an odd multiple, co-function, or if you have a co-function, remove and write. If you have an even multiple, then you will get the same function. Now, keeping this small logic in mind, cos of 180 minus theta is minus cos theta, because cos is negative in the second quadrant. Tan is also negative in the second quadrant. Cot is negative in the second quadrant. Secant is negative in the second quadrant. Cosecant will be positive, right? So sine and cosecant are positive, if you can observe this, and all the remaining values are negative. Got it? And here what we are observing, it is 2 into 90. 2 into 90, 2 is an even number, so even multiple of 90, therefore you are getting the same function, right? Now, the same logic we will apply for 180 plus theta also. 180 plus theta is in the third quadrant. So in third quadrant, what will be the positive ratios? That will be tan and cot. All the remaining will be negative. At the same time, 180 is nothing but 2 into 90. 2 is an even multiple, therefore you will get the same function, right, children? So keeping that in mind, quickly we will try to see the remaining formulae. Cos of 180 plus theta will be minus cos theta, because cos is negative in the third quadrant. Tan is positive, cot is positive, secant is negative, and cosecant is negative. Hope you got that, right? So you have tan and cot positive in the third quadrant, but all the remaining are negative. And at the same time, in your answer, you're getting the same function because it is an even multiple of 90, right? And the other way to remember is, if you have 180 directly, you can say it is the same function. When you have 90 into something, then you can think of even and odd. Okay, right. Then quickly we will look into the next set of formulae. That is 270 minus theta, 270 plus theta. Right. 270 minus theta, it is in the third quadrant. What are positive? Again, tan and cot will be positive, isn't it? All the remaining are negative. Now look at this 270. 3 into 90. What type of a number is 3? It is an odd number. So odd multiple of 90 again. So the logic what we have followed for 90, the same we are following for 270 also. But only thing is, sign will be changing because we are in a different quadrant over here, right? So cos of 270 minus theta is minus sine theta. Minus is because it is in the third quadrant. Okay. Then tan, it is positive because third quadrant tan is positive, and it is 3 into 90, 3 is odd. Therefore, you are getting a co-function. Cot 270 minus theta is tan theta. Secant of 270 minus theta is minus cosecant theta because secant is negative. Secant is negative. Therefore, you are getting a minus sign, right? Cosecant of 270 minus theta is minus secant theta, because 270 minus theta, third quadrant cosecant is negative, and 3 into 90, it is an odd multiple. Therefore, you're just taking off this co and you're writing it as secant theta. And likewise, We are taking 270 plus theta, which is in the fourth quadrant. So just observe, children. Just observe what are positive. What are positive over here? Only cos and secant. Cos and secant values are positive and the remaining are negative in the fourth quadrant. So the same thing we have taken here. Got it? And 3 into 90. So you just observe, if you have function without co, you are taking co-function of that. If you have a co-function, then you are removing it, removing that, and you are writing it. Okay. Now 360 minus theta. 360 is 4 into 90, even multiple. So you will have the same function. And 360 minus theta, it is in the fourth quadrant. Therefore, what will be positive? Only cos and secant will be positive. All the remaining are negative. Okay. So look at this. 4 into 90. Therefore, in all these formulae, you can observe you are getting the same function. You are getting the same function. But signs are not same as this, because you have 360 and what are positive and negative, that will be decided by Astc property. So in this you have cos positive and secant positive. So you can find the two values to be positive and all the remaining are negative. Got it? And 360 plus theta or minus theta, you will have the same function, like how you have taken for 180. Okay. Now 360 plus theta. So again, it is coming to the first quadrant. In first quadrant, all are positive. Just observe this. So for every formula, you are getting a positive value over here. Got it? And then once you get all the positive values, see 360 plus theta, positive. Then 4 into 90. 4 is an even number. Therefore, you are getting it as same function. So from all these, 6 into 8, 48 formulas. Now, what is that you need to remember? Only two concepts. If it is some odd number into 90 plus or minus theta, then you will get a co-function, or you will, if you have a co-function, you will remove and write, right? And then if you have an even multiple, then you will have a same function. That is point number 1 to be remembered. Then the second point you need to remember is Astc property. What is this Astc property telling you? It will give you the sign of the function which you are writing. All right, children. So don't get scared by seeing all these formulas. Now, if you are good at these two concepts, what I told, then you can write all these 48 formulas just simply like that. Okay, right. Now, quickly, we will see few problems based on this. Prove that cot pi by 16, cot 2 pi by 16, cot 3 pi by 16, and so on, cot 7 pi by 16 is equal to 1. Now, how to prove this? First, we will take the LHS part. Now, what is this LHS telling you? Here, he's not stopping here till cot 7 pi by 16 you are taking. That means you have cot 4 pi by 16, 5 pi by 16, and 6 pi by 16 also. Okay, children? Right. Now, 7 pi by 16. What is pi? Pi is 180. Remember always. Okay. In the beginning, if you feel that it is difficult to understand, you can convert it into degrees and you can solve the problem. Okay. Until you get acquainted with radian measure. Right. Now, 7 pi by 16. We can always replace it with pi by 2 minus pi by 16. Why this conversion? 7 pi by 16, what is pi by 16, children? Pi by 16 is nothing but, 180 by 16, isn't it? So 180 by 16, when you take, it is not a standard value which you have seen till now, isn't it? So we will try to convert that into a form where you can write the standard form, or that is one point to be kept in mind. Or we know another logic, that is cot and tan both are complementary, right? The cot can be converted to tan, or tan can be converted to cot. Just now we have seen that formula when you are writing it as 90 plus theta or 90 minus theta form. Got it? So the second technique will work out here. Let us see. Okay, 7 pi by 16, we are writing it as 90 minus pi by 16. So instead of 7 pi by 16, I can replace this. Similarly, 6 pi by 16, we can always write it as pi by 2 minus 2 pi by 16. How? Just look at this. Your LCM is 16 here, right? 16. Right. So 90 minus pi by 16, it is giving you 7 pi by 16. Got it. Similarly, 6 pi by 16 is, if you can simplify this, you can very well get the same thing. And also 5 pi by 16 is 90 minus 3 pi by 16. So we will try to replace it, replace all these values here with cot. So cot of pi by 16 into cot of pi by 2 minus pi by 16. Cot of pi by 2 minus pi by 16. So here we are writing it as 7 pi by 16 is nothing but pi by 2 minus pi by 16. That is when you are taking the LCM as 8, it is 8 pi minus pi, which is 7 pi by 16. So this one and the first term we are clubbing together. Why? Cot of 90 minus pi by 16, you can replace it as tan of pi by 16. In the identities list, we have seen tan theta into cot theta is 1. So this can be replaced by tan pi by 16. Now similarly, cot 2 pi by 16 and cot pi by 2 minus 2 pi by 16. This is nothing but tan 2 pi by 16. That is the reason why we are clubbing both the terms. Then cot of 3 pi by 16 and cot pi by 2 minus 3 pi by 16. This value is nothing but 5 pi by 16. Now what is left? 4 pi we didn't take. See, this is 7 pi by 16. This is 6 pi by 16. This is 5 pi by 16. 4 is missing. So we will write it. So cot 4 pi by 16 is nothing but cot pi by 4. Okay. Now we will replace the 90 minus thetas with their formulae, children. So cot pi by 16 into tan pi by 16, cot 2 pi by 16 into tan, this is tan 2 pi by 16, and cot 3 pi by 16 into tan 3 pi by 16 into cot pi by 4. What is cot pi by 4? Cot 45. Cot 45 is 1. Now when the terms are getting cancelled here, in every bracket you will be left with 1. So 1 into 1 into 1 into 1, it gives you 1. Therefore cot pi by 16, cot 2 pi by 16, cot 3 pi by 16 into cot 7 pi by 16 is equal to 1. Right? So directly if you start simplifying, maybe you may not be in a position to complete the problem so easily and so quickly. Okay, one more problem. If tan 20 is equal to P, then prove that tan 610 degrees plus tan 700 degrees by tan 560 minus tan 470 degrees is equal to 1 minus P square by 1 plus P square. Okay, children, as I was mentioning, we are discussing till 360 only. Then how is that you are getting more values? Now here, if you can observe this, children, because of the periodicity of the trigonometric ratios, you can take any angle and you can just reduce it to the angle which you know. Okay, that we will see here. Now you are given that tan 20 is equal to P. Okay, now we'll take LHS first. Then 610 degrees. First, we will try to convert in terms of 90 minus theta and 90 plus theta form. Okay, so 610, you can always write it as 7 into 90 minus 20. 7 into 9, 630 degrees minus 10. Minus 20, it gives you 610. Now, similarly, 700 degrees, that you can take it as tan of 8 into 90 minus 20. Then 560 degrees, you can write it as 9 into 60, 6 into 90, that is 540 plus 20, it is 560. Now 470, you can write it as 5 into 90, which is 450 plus 20, which is nothing but 470 again. Right. Now, I have taken as multiples of 90. You can always write it. You can always write it in as multiples of 180 and 360 also, whichever is convenient to you. Right. Now, observe this, children. Tan of 7 into 90 minus 20. 7 into 90 minus 20. Now, if you can observe your 4 quadrants. Now, if it is 4 into 90, it comes to the 4th quadrant. But it is 7 into 90, that is, it is coming to the 3rd quadrant, because 7 into 90 minus 20. So it falls in the 3rd quadrant. In 3rd quadrant, tan is positive. So you'll get a plus sign. But it is an odd multiple of 90. Therefore, you'll get a co-function. So you will have it as cot 20. Got it? Now here, 90 into 8 into 90 minus 20. That means if it is taking up to 8, that is 8 into 90, this 8, if you divide by 4, then you will get what? You will get it as 2 rotations. 90 into 4 will give you 1 rotation. 90 into 8 will give you 2 rotations. Now 2 rotations, if you complete, then you will come to the initial position, but you are short by 20 degrees. So it is falling in which quadrant? It is in the 4th quadrant. In 4th quadrant, tan is negative. So minus. This is an even multiple of 90. Therefore, you will get same function. So you will have minus tan 20. Got it? Now, this is 6 into 90 plus 30. Now, if you take up to 4, 1 rotation, then one more 90, you will go to 90 degrees place, and then 180 degrees if you reach, then it will be 6 plus another 30. That means this is in the 3rd quadrant. Got it? So in the 3rd quadrant, tan is negative. I'm sorry, in the 3rd quadrant, tan is positive. So you will get a plus sign. Here you have an even number. Therefore, you will get same function. So it is tan 20. Now, this is 5 into 90 plus 30, 90 plus 20. That means in which quadrant it is falling? It is in the 2nd quadrant. In 2nd quadrant, tan is negative. And at the same time, this is an odd number. Therefore, you will get co-function. Therefore, you will get it as already you have a minus, right? And this is minus cot 20 degrees. So minus of minus, which gives you plus. So we will look into this, children. This is what is the previous, step. So if tan 20 is P, what will be cot 20? Cot 20 will be 1 by P. Wherever you have cot 20, you replace it with 1 by P. So 1 by P minus P by P minus of minus plus 1 by P. All right. So you have it as, take your LCM in the numerator, it will be P. So you will be getting it as 1 minus P square. In the denominator, your LCM is P again. So P square plus 1. P and P, the denominators, both the denominators, they get cancelled, and you will be left with 1 minus P square by 1 plus P square. Therefore, we can conclude saying tan of 610 degrees plus tan 700
Usha madam, please unmute. Please unmute your video, audio.
Madam, am I audible?
Yes, ma'am. Please go ahead.
Madam, am I audible?
Yes, ma'am. Please go ahead.
Okay. Right. If secant theta plus tan theta is equal to 5, find the quadrant in which theta lies and find the value of sine theta. Find the value of sine theta. Okay. Now this is what you need to calculate, children. So you are given that secant theta plus tan theta is equal to 5. Right. Now, as I was mentioning, from the identities, secant square theta minus tan square theta is equal to 1. So secant theta plus tan theta into secant theta minus tan theta is also equal to 1. This is what we have deduced from that identity. So we will try to make use of the same thing over here. So first, whatever is given to us, we will call it as equation number 1. Then we know the identity secant square theta minus tan square theta is equal to 1. Therefore, this implies secant theta plus tan theta into secant theta minus tan theta is equal to 1. So instead of secant theta plus tan theta, we will just take it as 5 and shift to the other side. Right. So secant theta minus tan theta is equal to 1 by 5. So we will call this as equation number 2. We will call it as equation number 2. Then equation 1 and 2, we will solve them. When we solve, secant theta plus tan theta is equal to 5 and secant theta minus tan theta is equal to 1 by 5. Tan theta with positive and negative signs, they get cancelled. So you will have it as 5 plus 1 by 5. If you take LCM as 5, you will be left with 26 by 5, children. So secant theta plus secant theta is 2 secant theta is equal to 26 by 5. So secant theta is nothing but 13 by 5. What is secant? What is that you need to calculate? You need to calculate sine theta. Okay. Secant is what? Secant is hypotenuse by adjacent. So adjacent value is 5 and hypotenuse is 13. So by applying Pythagoras theorem, you can always calculate the opposite side, which is equal to 12. Now, once we know opposite, adjacent and hypotenuse, we can always write sine theta value. Sine theta is nothing but opposite by hypotenuse, which is 12 by 13. Now observe this, children. You are getting sine value as positive, which involves opposite side, and secant value is also positive, which is involving adjacent side. Both adjacent and opposite values are positive. And of course, the hypotenuse will be always positive because you are taking sum of squares of, even if they are negative also, it becomes positive, isn't it? So once opposite and adjacent both are positive, we can conclude saying that theta lies in the first quadrant. Theta lies in the first quadrant. Now, these are some of the application problems of what we have discussed today. Regarding the sign of the trigonometric ratios and their formulae and some identities. Now, here are some practice questions, children. Hope that you will solve this today itself immediately after your class.
I'm sure you will get the solutions also comfortably. And try to remember the logic, what we have taken for writing all those 48 formulae, right? Astc property, and also, if it is an odd multiple and even multiple, I left with some small technique how to remember, isn't it? So thank you all. You can take the screenshot of this, children. Thank you.
Thank you, Usha madam.
Thank you, madam.
Elaborate session. Students, if you learn trigonometry of whatever madam has taught you today, it will not be difficult for you to solve any question in trigonometry. Whatever trigonometry ratios or identities and the angle lying in which quadrant, how to identify whether it is positive or not, the signs of trigonometric ratios, everything is discussed in detail by madam. If you are perfect with what all is taught today in this one session, you will have no problem in learning in future. Trigonometry will be just a cakewalk for you if you know all these things in detail, as madam has given you step by step. Very minute detail also was given to you. Hope and I'm sure you will get benefited because of this, and you will revisit this slide again, make a note of all the important points, and then you yourself will practice. Madam has also mentioned, no, to learn mathematics is to do it constantly. So learning mathematics means practicing mathematics every day regularly, and if you do it on your own, there's nothing like it will, because you have chosen mathematics as your optional. That means you're interested already in learning mathematics. Now, to make it more interesting and easier, you need to have strong basics. Those basics of trigonometry have been discussed today in detail by ma'am. Madam, that was like for anybody, whoever does not know trigonometry, any basics, this session will make it so clear to them, and they will have no problem in learning trigonometry further. Thank you so much for such a detailed explanation. Thank you.
Thank you, madam.